Organic chemistry. Okay, let's be honest, for a lot of us, those two words bring back some not-so-fond memories of late nights and diagrams that look like scribbles. But what if I told you it's not some scary, impossible subject? What if it's actually the secret language of the entire world around us? A hidden code that explains, well, almost everything. Let's dive in and crack that code together.
I mean, just think about the fact that you're watching this right now. The very first thing that happens in your eye to let you see, that's an organic chemistry reaction. A molecule inside your retina literally twists its shape. It's called cis-trans interconversion. And that tiny little move is what kicks off the entire biological signal for sight. It's not magic, it's just really, really cool organic chemistry.
Or how about life-saving medicines? You've probably heard of statins, right? Millions of people take them for cholesterol. So how do they work? Well, they're basically these perfectly designed little molecular machines. They are organic compounds built to fit into one specific spot in your body, like a key into a lock, blocking a process at the molecular level. That's organic chemistry acting as medicine.
And it's not just inside our bodies. That non-stick pan you used this morning, that's Teflon. It's a type of plastic, a polymer, that was discovered completely by accident. It's just a long chain of carbon and fluorine atoms, but its unique slippery properties come straight from the rules of organic chemistry.
So you've got your eyesight, a life-saving drug, and your frying pan. What on earth is the common thread here? How can one single field of science connect all of these totally different things? Well, the answer is actually pretty simple. It all comes down to one incredible element. And that element is carbon. Yep, carbon. At its heart, organic chemistry is really just the story of what carbon can do. You can think of it as the ultimate Lego brick of the molecular universe.
And yeah, the official definition is pretty simple. It's the study of compounds based on carbon. But that simple definition hides this unbelievable world of complexity. I mean, pretty much all of the molecules that make life itself possible, your DNA, proteins, all of it, they're all organic compounds.
So, you have to ask, why carbon? What's its secret sauce? Well, it's a master networker. It can form 4 super strong, stable bonds all at the same time. This lets it build this incredible variety of structures. We're talking long chains, complex branches, stable rings. It is the absolute perfect scaffolding for building all the complex stuff life needs. Now, faced with all this complexity, a lot of people think organic chemistry is just a giant memorization game. But that is the single biggest misconception out there. The absolute best way to tackle it is to think of it not as a list of facts, but as learning a new language. And hey, don't just take my word for it. The author of the textbook we're pulling from, Paula Yerkenes Bruce, says it perfectly. The whole point isn't to memorize, it's to see the patterns, to find the shared features, the big ideas that tie it all together. It's about learning the rules of the language. So how does this language work? It kind of breaks down into 3 simple steps. First, you learn to group molecules into different families. Think of these as your vocabulary, the nouns and the verbs. Second, you figure out that every molecule in the same family pretty much behaves the same way. And third, you realize all these different families can be sorted into just 4 main groups. And those are like your grammar rules, telling you how all the words fit together.
And this is where it gets really cool. For instance, you've got the alkene family, which has a carbon-carbon double bond. All that means is 2 carbons are sharing a little extra, which makes a reactive spot that's the starting point for a lot of plastics. Or the alcohol family, which has that little OH group. You see that in everything from hand sanitizer to a pint of beer. The point is, once you can spot the family, you can start to predict what it's going to do.
Okay, so this is the crucial leap. Because once you understand the words and the grammar of this molecular language, you don't just have to read it. You can start to write with it. You can become a molecular architect, designing and building brand new molecules from scratch. This is where OChem goes from a science of understanding to a science of pure creation.
And get this, chemists have this incredibly clever strategy they use. Instead of starting with a pile of simple ingredients and trying to figure out how to build something complex, they often start with the final molecule they want to make, and then they work backward, step by step, to figure out where they needed to begin.
This cool approach has a name, of course. It's called retrosynthetic analysis, and it basically turns the whole challenge into a logic puzzle. It's less like following a recipe and more like being a detective, solving the mystery of how a molecule could possibly have been made.
So, as we start to pull all this together, I want to leave you with what I think is the single most important idea here. Organic chemistry isn't just another subject in a textbook. It is the fundamental bridge that connects the simple world of atoms to the incredibly complex world of biology and everything beyond it. Our source materials author calls it the bioorganic bridge. And honestly, that's the perfect way to put it. It's the discipline that lets us translate the basic rules of chemistry into the actual language of life. Without it, things like biochemistry or modern medicine would have huge gaping holes in them. You can see right here how it's the foundation for pretty much every modern life science. Understanding how our bodies work, how DNA stores information, how to design new drugs, how to create new materials, you name it, all of these fields are built on the principles of organic chemistry. It really is the central science.
So, the next time you hear someone say organic chemistry, don't just think of it as a hard class. Think of it as the blueprint for life and for technology. From the painkiller that eases a headache to the plastic in your phone, it is all just an elegant dance of carbon compounds. And the most exciting part? We're still learning the steps. The question isn't just about what we already know, it's about what we're going to choose to design next.